Welcome to Spaceverse, your portal to cosmic adventures. In a universe filled with colossal structures and celestial phenomena, galactic collisions are among the most awe-inspiring events we can witness. And thanks to the cutting-edge technology of the James Webb Space Telescope, astronomers have recently captured an extraordinary example, a pair of merging galaxies so unique and expressive that it looks like the universe itself is smiling. Let's talk about ARP-107, a cosmic collision that has both scientists and space lovers buzzing with excitement. Because this isn't just another galactic crash, this one is putting on a show, and it's giving us a front row seat to the intricate ballet of galactic interaction. First things first, what exactly is ARP-107? ARP-107 is the name given to a pair of interacting galaxies, one a large spiral galaxy, the other a smaller elliptical galaxy, that are in the middle of merging. This duo is located about 465 million light-years away from Earth, nestled in the obscure constellation of Leo Minor. Now, 465 million light-years is a long way from here. To put it in perspective, if you hopped on a spaceship traveling at the speed of light, 300,000 kilometers per second, it would still take you 465 million years to get there. That's older than the dinosaurs. Older than Earth's earliest plants. We're peering deep into the ancient past of the universe. So how do we see it? Thanks to the James Webb Space Telescope, humanity's most powerful eye in the sky, we can now observe galaxies like ARP-107 in unprecedented detail. Using its two primary cameras, NIRCam near-infrared camera and MIRI mid-infrared instrument, Webb captured the merging galaxies with stunning clarity. The resulting image revealed something unexpected, a smiling face in space. Yes, really. Among the swirling chaos of colliding galaxies, a bright white bridge of stars, nearly transparent, stretches between the two galaxies. It's been ripped from both, creating a kind of luminous arc. Below that, star-forming regions of gas and dust light up in shades of orange and red, forming what looks like eyes and a mouth. To the human eye, the result looks almost cartoonish, as though the universe itself paused for a selfie. But behind this cosmic smile lies a powerful scientific story. Let's zoom in on the spiral galaxy, the larger of the two. This galaxy is no ordinary spiral. It's classified as a Seyfert galaxy, a type of galaxy that is considered active. Active galaxies emit large amounts of energy from their cores, powered by intense activity near their central supermassive black holes. And Seyfert galaxies are a special subset of these active galaxies. They're named after American astronomer Carl K. Seyfert, who first studied them in the 1940s. While they don't shine quite as brightly as quasars, the more extreme class of active galaxies, Seyferts are actually easier to study. Why? Because they emit energy in lower wavelengths, including infrared light, which the JWST is specially designed to detect. That makes ARP-107 an ideal subject for Webb. By using infrared observations, scientists can see past the dust that often clouds galactic centers and get a clearer view of the dynamic processes happening during a merger, especially the birth of new stars. And speaking of star formation, ARP-107 has a lot of it. The bridge of stars between the galaxies isn't just pretty, it's evidence of intense gravitational forces at play. As the galaxies approach one another, their mutual gravity pulls on their structures, tearing out stars, gas, and dust into vast tidal streams. That gas and dust are the raw ingredients for making stars. So when these materials are compressed during the collision, it triggers star formation. This is what we're seeing in those orange and red regions, newborn stars lighting up their dusty nurseries. It's a stellar fireworks show in slow motion. But not all galactic collisions are helpful to star birth. In fact, it's a bit of a double-edged sword. On one hand, as we see with ARP-107, the collision can compress gas and spark star formation. This is especially true for galaxies that were previously quiet, with little or no star formation activity. The merger brings in fresh material and revs up stellar production. On the other hand, collisions can also have the opposite effect. Instead of compressing gas, some mergers scatter it, flinging it out into intergalactic space, far from the gravitational pull of the galaxy's center. Without this gas, the galaxies are deprived of their star-making fuel, and star formation can actually shut down. So far, ARP-107 seems to be on the productive side of that equation. But it's far from finished. This galactic dance is expected to continue for hundreds of millions of years. As time goes on, the spiral and elliptical galaxies will continue pulling each other apart, merging more and more of their stars, gas, and dark matter into a single, new structure. Eventually, when the collision completes, they will no longer be distinguishable as two separate galaxies. Instead, they'll form a larger, irregular galaxy, a cosmic chimera, made from the pieces of both. This future galaxy may have very little in common with its ancestors. As we've already seen, the spiral arms of the Seyfert galaxy in ARP-107 are already being disrupted. While the core remains intact, those once majestic arms are being shredded, leaving behind only traces of their original spiral form. This is a stark contrast to another famous galactic interaction, the Cartwheel Galaxy. The Cartwheel Galaxy, which JWST has also imaged, is another spectacular case of cosmic collision. In that system, a smaller galaxy passed almost directly through the center of a larger one. That collision sent out waves of gas and stars in a circular pattern, like ripples on a pond. The result? A stunning galaxy that looks just like a wheel, complete with spokes and a bright outer ring. But ARP-107 didn't follow that same trajectory. In this case, the smaller elliptical galaxy was off-center when it collided with the spiral galaxy. That made all the difference. The collision was less symmetrical, less focused. So instead of forming a ring or a ripple, ARP-107 produced a distorted spiral, with arms torn apart asymmetrically, and of course, the smiley face of star-forming regions that's got everyone talking. Each collision tells a different story. And this is what makes the James Webb Space Telescope so revolutionary. Its ability to observe in infrared gives it an edge over previous observatories like Hubble, which primarily sees visible light. With JWST, we can peer through cosmic dust, explore hidden star nurseries, and trace the faint structures of gas and stars that would otherwise remain invisible. It's not just about pretty pictures, although those are amazing too. It's about understanding how galaxies form, evolve, and die, how black holes shape their environments, how stars are born, and how they shape the chemical makeup of the universe. ARP-107 is one small piece in a much bigger puzzle, but it's a piece that helps us connect so many others. As the merger continues over the next few 100 million years, astronomers will be watching closely. Not just to admire the cosmic smile, but to study the structure, composition, and motion of the galaxies in exquisite detail. What kinds of stars are being formed? How are the gas flows changing over time? How is the Seyfert core evolving during the collision? Thanks to JWST, we now have a tool powerful enough to answer these questions and many more. So the next time you look up at the night sky, remember, the universe isn't just filled with stars. It's filled with stories of birth and destruction, of chaos and harmony, of galaxies that crash, collide, and sometimes smile. If you enjoyed this journey into the cosmic collision of ARP-107, be sure to give this video a thumbs up and subscribe to Spaceverse for more deep dives into space discoveries, JWST updates, and the mysteries of our ever-expanding universe. Until next time, keep your eyes on the stars and your mind open to the cosmos.